All right, so topic 2 video, as promised, we're going to go over 2 examples actually for how to do the chain rule. And my goal is to show you that it can be a very smooth process. So there's a few ways I could write out the examples. I could try to write down everything I'm thinking, but I think that's just going to make it look more complicated than it is. So I will show you these 2 examples, and I'm going to try to do it as smoothly as possible to hopefully inspire you to see where this is going. If you need me to fill in any extra details on how to help you organize it, if for some reason this process seems a little too quick for you, please feel free to ask me in class. But my goal is to not overcomplicate a rule that is meant to be kind of pretty simple and straightforward. So let's review. I saved this for us so we can remember. We're talking about the chain rule. The chain rule says when you have a composite function, you take the derivative of the outside function times the derivative of what's inside. Okay, so here, let me write down an example for us. In fact, that's a little too dark. Let's do a lighter color. Since we talk so much about y equals sine of x squared plus 3, I thought, hey, why not derive it? We've already decided what the outside function is, which is sine. And the inside function we've decided is u, x squared plus 3. That's the inside function. Okay, so the chain rule says we can find y prime simply by saying the derivative of the outside function, which is the derivative of sine, is just cosine. So all I write is cosine of u. Now, I already know that u is x squared plus 3, so I'm just basically it's going to feel like you're doing something wrong. Like, how can I just derive sine of x squared plus 3 and just say it's cosine of x squared plus 3? Well, you can't, so don't worry. We're gonna fix it. But the derivative of the outside function is just cosine of stuff. Then the rule says we took this. Now let's take the derivative of what's inside. The inside function is x squared plus 3. We know the derivative of x squared plus 3 is just 2x plus 0. So multiply it by 2x plus 0, or just 2x. And rewriting this just to make sure nobody gets confused, that 2x is on the outside of the cosine function, right? We're just multiplying the cosine by the rest, so we'll write it like this. 2x cosine x squared plus 3. And that's it. That's all you have to do. Was that easier than you thought? That's a rhetorical question, I guess, since you can't answer me right now. So that's it. You just take the derivative of the outside function, which was saying the derivative of sine is cosine. So we just said cosine of the stuff and left it that way, times the derivative of what's inside. And that's where we acknowledge that this is not just a simple sine of x function. We derive the 2x, and it works. And if you're wondering, again, like, how is that possible? Well, it's all based on this. The derivative of y with respect to x, you're allowed to just derive one part and then derive the other part and just multiply it together. And it will give us the answer. So that's what we're doing here. That was it. So our derivative is just 2x cosine of x squared plus 3. Done. All right, let's do another one, just in case you're not convinced. You can pause it if you didn't get to write all that down for some reason, but I'm going to erase and give you another one. So example 2, we're going to call our y function, we'll say tangent of 5 minus sine of 2t. Now I'm really going to try to make it crazy. Case you think your eyes might be playing tricks on you, this is indeed a chain function with 3 parts. Oh my gosh, I know. What am I thinking? So we have an outside function, tangent. We have an inside function, 5 minus sine of 2t. But we have another one inside that. What? That would be 2t right here. Chain rule is we can make it into a 3-part problem. We can do it this way. Ready? Instead of breaking it into 2 pieces, we could make it dy du, du dv, dv dx. Right? Doesn't that all work out? That all still will work out to finding the derivative of the first one. So it's going to be the derivative of the outside function times the derivative of what's inside times the derivative of what's inside. Just 3 steps, 3 functions, 3 steps. Let's see if we can do this without getting too stressed out. Okay, first, what is the derivative of the outside function, tangent? Well, we know from our prior experience that the derivative of tangent is secant squared. So what we do is we just say secant squared of all the stuff, and we keep all the stuff just the way that it is. 5 minus sine of 2t. Then we're going to move to the next level. You know what, I will do it in another color just so that we don't get confused. Times the derivative of what's inside, the next level down. It's like unwrapping a package. You know, have you ever unwrapped one of those gifts within a gift within a gift, and then you get down to the bottom, it's this tiny little gift, but it's like really awesome because you had to unwrap 10 gifts to get there? Well, that's kind of what we're doing. Unwrap the outside, move to the next one, move to the next one. Next level is 5 minus sine of 2t. We're going to ignore the 2t part because that's like the inside part. We're just going to look at it at face value. What's the derivative of 5 minus sine of stuff? Well, the derivative of 5, first of all, is 0, so we can kind of ignore that. The derivative of sine is cosine, but this is negative sine, right? So negative sine, the derivative of negative sine would be negative cosine, since the derivative of positive sine is positive cosine. So here's what we say. Times 0 minus cosine, but we'll just say minus cosine of stuff, right? This is the stuff. We just leave it there because we're allowed to do that. We're just taking the derivative of the next level, and we can leave the stuff that's inside the way that it is. So again, the reason that this 5 disappeared is just because the derivative of 5 is 0. All right, 2 levels down. We did the derivative of the tangent function, secant. By the way, I don't know if I said this out loud, but this is supposed to be secant squared, right? I think I said that out loud, but I didn't write it. Or at least I meant to. My apologies. Okay, derivative of the outside function. Derivative of tangent is secant squared of stuff. Derivative of the inside, or at least the closest, the next level, is negative cosine of stuff. Now we take the derivative of the smallest, the one on the very inside, which is 2t. Well, the derivative of 2t is just 2, right? It's like 2x. Derivative of 2t is just 2. And then we're done. Layer 1, 2, 3. Multiply them all together. That's it. Let's rewrite it in a slightly more organized way. We know y prime is going to be, well, we have a negative here and we have a 2, so I might as well make this negative 2 at the front. Secant squared of 5 minus sine of 2t times cosine, because I already moved the negative, so it's just times cosine of 2t. And that is that. And if for some reason, actually I'm looking at this, somebody might get confused that the cosine of 2t is inside the secant function. If that's the case, you can actually move it to the front to make it clear, although honestly then you'll have the same, you want to make sure that they know that the secant is not on the inside. So if you really are concerned about that, you could put, I'll do it in yellow so you can see, you could actually put like negative 2 times secant squared of all that times cosine of 2t. And that would work. Actually, also I'm thinking about if I was writing on an AP test, how could I do this to make it most clear? I might do it like this. Cosine of 2t times secant squared of all that stuff. Yeah, that makes it look a little bit better. Oops, wrote right off the edge there. So it doesn't really matter what order you write it in. I'm just giving you some different options. It's always important to make it clear that the cosine function is outside of the secant function. We are just multiplying. We're not layering. We're just multiplying all the pieces because, again, that's how the chain rule works. We just take the pieces, multiply them all together in a row. That is how the chain rule works. Now, it can get a little messy when there are multiple layers, but it doesn't really get like overly complicated. Like, I don't want you to feel like your numbers are all going to get twisted up. You're just taking derivative of a chunk times the derivative of another chunk times the derivative of another chunk. And as long as you can visualize those layers from the outside moving in, you should be able to just kind of write it out. We will be practicing with this to make sure that we work out any little knots in our process, but that is it for the chain roll, and we'll do the rest in class.